Hello and welcome to TechMaven Geospatial's Tile Server, a very powerful purpose-built Windows application for serving map tiles. It supports MBTILES and delivering that as XYZ or WMTS URLs. It's very easy to use. You can rapidly load tiles or a text file listing of a bunch of map tiles. It also serves static GIS data, so you may load a GeoJSON or a KML or GPX or CSV or other file formats and serve those as an HTTP endpoint and available. How do you find all the URLs? Well, we have a listing here of all the endpoints available, from mapping services to the mapping clients to other endpoints, as well as data distribution. And we have a very friendly web page called our Discover web page, which is able to show everything. So anybody on this network, whether it's an edge server running on a laptop or something running in the cloud or on-prem or any type of implementation, you're able to see and get access to these URLs and copy them and add them to your mapping application. One of the awesome things about this application is the ability to do vector tiles to raster tiles. So it supports both the TechMaven Geospatial produced OpenStreetMap vector tiles that we produce on a monthly basis, as well as MapTiler data, OpenMapTiles format of their OSM vector tiles. Once you load an OSM vector tiles, here's an example of one, you can configure a style sheet of how you want it to be rendered. And so we have pre-configured styles, but you can also load 5 custom styles when you create them. In addition to that, you can create what we call a tile group. And a tile group lets you merge and composite multiple tile layers together. So if you want to create a topo terrain style that has the OpenStreetMap vector tiles, hillshade, raster tiles, contour lines, vector tiles, and overlays, you're able to do that and render a really nice topo terrain style. If you want to create a satellite hybrid, you can do that as well, where you provide the OpenStreetMap vector tiles and the satellite, and you choose our satellite style. Now you'll have place names and some roads and other stuff that gets added on top of the satellite imagery. And you can create other types of things like that as well. When you create a new tile group, you can pick the pre-made styles or load your own styles if you have any there. We have a special screen for that. The app will work with the ability to set a domain and a certificate for encryption. And let me show you what that screen looks like. Okay, so we're into settings. It will work with multiple IP addresses. So if you have a server that has multiple network cards, or an internal IP and a public IP, or whatever the case may be, you can pick the IP address you want to use. You can enable a domain. This could be just a name you pick and you want to have a host file created for that. So something local instead of an IP address. And then you can load a PFX file for getting HTTPS and enabling that. There's also the ability to do tile caching for the vector to raster, and you can manage your tile caching that you've set. So let me show you how the tile caching works. So let's say I wanted to create tile caching for the topo terrain style. It brings up this caching option here, and I can go to where I want to build the cache. You could create multiple caches. So maybe I'm doing a project in India here. I can define my area. I'm going to do something around this area. There's my bounding box, or I could paste in a bounding box if I have one. And then I can modify the zoom levels that I want to build a cache for. Maybe I only care about a couple zoom levels. I can do that, and then the server will build the cache and use the cache instead of building it dynamically. The other option that you have in this awesome application is the ability to distribute data. So the source raster tiles, vector tiles, terrain tiles, and static GIS data, as well as the cloud optimized geotiffs, anything that's being served as zip files, 3D tile archives, all those things are available in the data distribution endpoint. So this is the API readable endpoint, a JSON response, right? So you can build integration into your applications. But the Discover web page has the ability to download each of those. So in the let's say I wanted this one here, I could download this. This would be the link to copy to download that, or click to open it up and download it. So you would open this up in your end user device, and then you'd be able to download that source data as an edge server. The other option, we're helping to serve data to ATAC and WinTAC customers. And so we have an ATAC endpoint which builds a zip file of all the Tile.xml configurations. And so each layer has its own Tile.xml, whether it's a tile group or an individual tile layer. And rather than you downloading all of these, we'll build the zip file of those, and you'll be able to load that zip file into your Android and load that into ATAC. For WinTAC, you need to individually load an XML file. It doesn't accept the zip file. And then you'll be able to configure that without having to copy and paste URLs and things like that. In addition to that, this can rapidly stand up a common operating picture map. So we include two very advanced mapping engines. One is a 2D map with lots of tools and widgets. So anybody can open that up in /map, anybody on any browser anywhere. This could be on a mobile device, a tablet, a phone, or laptop, a computer, anywhere. And one of the great things about this is that the ability to connect to the tile server through the endpoints that are available. So we have a services endpoint, which lists all the tile layers. We have a file list endpoint, which lists all the files. We have a cog endpoint. And so you can rapidly add the data without having to deal with URLs. But if you wanted to deal with URLs, both internet or from the tile server, you can connect to pretty much any Esri or OGC mapping URL and do that. And this application lets you create data, edit data, even do WFST if you have GeoServer or QGIS server running, and integrate and mash up local data. So whether it be a shapefile or geopackaged features or GeoJSON or KML, this is our advanced 2D mapping engine that's very ready to go to leverage in that capacity. The really cool thing about this is that if you can build a configuration and save a configuration. We call that our catalog. And so we have a catalog generator tool, and this allows you to beforehand generate a catalog. So I know I have an online KML file, I have an Esri map image, I have an Esri feature server URL, and then I can export this as this JSON file. I could share it into the app and make it available to the team. So we're able to serve catalogs. You can pick if it's the 2D catalog or the 3D catalog, and browse to that catalog. Then they become available, and you have published maps. In addition to that, we have the 3D catalog. The 3D map and its own catalog. And this also includes a 3D model converter, which will convert about 25 different formats of 3D models into GLB binary transmission format. The 3D map is based on cesium, and it includes 3D terrain and 3D buildings from cesium ion, and you're able to integrate in data from the tile server and any other local data. So if you click upload, you can see both local data, which you can even drag and drop into the browser, or web data. And web data, you can have it auto detect, or you can pick a certain type. But again, you can load a catalog just by dragging in the catalog or setting that URL there. And we have some pre-configured catalog here. We have the catalog that is you're able to add the 3D building. So let's say I wanted to go to I don't know, Boston or New York City or anywhere. Let's see here if I can go to New York. Let's go to New York City, and of course we're tilting. Now, on a phone, if you open this browser URL on a phone, it supports augmented reality, and you'd be able to move the map with the compass, accelerometer, gyroscope, and all that good stuff. So this is great for integrating your data as well as mashing it up with other internet data and doing all that. And it supports playback of spatial temporal data. So if you have a time-enabled WMS or if you have CSV with time data, you can load all that in there. If you have lots of data, you want to know where the extents of all these are, you can come over here and we have a GeoJSON endpoint, which builds a polygon from the extents of all the different data that you have loaded. Okay, I'm back. I'm going to show data loading now for the tile server. So as you can see, there's two ways of loading data. You can add MBTILES with the add tiles, or you can add files. And files includes everything from the static GIS data, like KML and GeoJSON and GPX, and 3D tiles archives, both .3D tiles and 3TZ, GLB, GLTF, 3D models, GeoTIFF, and other formats, CZML, zip files. Anyway, so you can load those files that way and get them able to be served. So let's just grab a file here from my drive. Let's figure out something that's easy that could be right here. I have a KML right here. Alright, so I added that, and that should appear in my files now. So there it is, and if I wanted to add that to a map, I could copy the URL, and now that's being served as a URL. So that's available now. Okay, now if I want to add MBTILES, well, I have a bunch of MBTILES loaded, so I'm not going to load any more. Let's go ahead and add our satellite hybrid. So I'm going to use QGIS and show you how you can load that. You'll see that we have a Tile.JSON URL, which is very useful when you're trying to discover this and learn the zoom levels and things like that. In the actual tile listing of all the data, we have this little eye, and this will let you jump in and view the metadata of these things. So you can, if you were curious what's in the metadata table, and what's the min and max zoom level and other details, you can jump in and view that metadata from there. Okay. All right, so let's grab a URL. Let's grab one of the tile groups like the satellite hybrid. So I'll just copy that URL. I'm gonna open up QGIS, and I'm gonna go to XYZ URL here, a new connection. Okay. I'm just going to call it tile server sat hybrid. Okay, and I'm going to paste in the URL. Make sure the placeholders came in correctly. You can adjust the zoom levels as needed. Okay. And I have a lot of stuff here, but let's find it. There it is. So I turn off this other satellite, and I should be able to see place names and satellite coming in together as one layer. And there we go. So let's grab something else. How about the topo style? So we can grab that. And if you don't want to use XYZ, you can use WMTS. So maybe you're using an Esri client and they're more adept at using WMTS. You can copy the URL here, which has all the layers. This generates the GetCapabilities.xml, and so all the standard mapping clients that know how to work with WebP tile service can read that. So we have compatibility and be able to show both, and in the near future we're hoping to be adding OGC API tiles, OGC API maps, and other endpoints available. Okay, so I'm going to grab this one here, copy that, bring it into QGIS. Okay, new.
paste in the URL, okay, and then go ahead and add it. So let me go to an area that has some mountains, somewhere in the Appalachians maybe, or in Oregon, Washington, wherever. So you'll see the hillshade be rendered, so we can get an idea of that data, maybe the Cascade range. As I zoom in more, we should start seeing contour lines coming in, as we added contour lines to this. And we have contour line labels. You can see some labels. So that's fusing together, 3 different layers into one, and being able to render that dynamically. So this is not pre-generated data. This is all coming in dynamically from the tile server. The other thing to note, it can serve, if you have a mapping client that can support cloud optimized geotiffs. These are geotiffs that have special overviews and compression and other specifications that let they do range requests and read portion of the data rather than loading the whole data. This can support that, and you can get a URL of ability to do that.